All right, this is your stat sensei, and we're going to do a second scenario on one sample T hypothesis testing. So you may want to have your recipe card off to your side because it lays it out for you, and your recipe is going to look something like this. So scenario 2, a credit card company wondered whether giving frequent flyer miles for every purchase would increase. So we're looking to increase something that probably indicates that I'm going to have an inequality of being a greater than sign, which has a current mean of 2,500 per year. Well, that current means that's my status quo. That's what things are. And so that means my population mean is currently 2,500, and we're looking to increase it. They gave free miles to a simple random sample. That's important because that's going to be one of our conditions of 37. So here's my sample size of 37 and found the sample mean, so this to be 2542, which is X bar. All right, now notice this is greater than that. So we're going to have some evidence that things change. Is it statistically significant? We'll figure that out with a standard deviation of 109. All right, so first off, that's my standard deviation. And since it came from the sample, that's my sample standard deviation. And if you have a sample standard deviation, you're using a T statistic. So our null hypothesis is that is 2,500 because that's our status quo. That's where things currently are. But we want to increase it. So we want to know our alternative was our method of giving frequent flyer miles successful increasing it. All right. So let mu equal the true population mean credit card usage for mileage or credit card usage for tickets after the mileage incentive. Now, you don't have to have all this, but I just want to be clear as to that's where it's after we have the incentive. Before the incentive, we know what it is, 2,500, but after the mileage incentive, did it go up? All right. Well, the conditions, the very first condition from our recipe card is we need a random sample. Fortunately, they told us it was. And generally speaking, they will. If they don't, you're going to have to say something along the line. We assume that it was randomly selected and it represents the population, all right? 37 divided by 0.1, or as we said before, you can just sit there and show the multiplication, 37 times 10. Either way, 307. And it's reasonable to assume that they have at least 370 credit card users. Please remember, the N is less than 10% of the sample is necessary for independence or to be independent enough. Number 3, our sample size is 30, which is greater than 30, or excuse me, our sample size is 37, which happens to be greater than 30. So the distribution of means, and it's really important you state it like this, is normal by central limit theorem. Please do not abbreviate it, all right? And actually, this needs a word that's missing, very important. The distribution of means is approximately normal. So please make sure you use the word approximately. They will dock you points if you don't. Since it's a T statistic, we're just going to write down our T formula, X bar minus mu, S divided by the square root of N. So let's draw our picture off to our side. And off to the side, we go, you know what? Currently, we have 2,500, and that's the mean of the population. And then our sample mean was 2,542. And we wanted to know whether or not what the likelihood of getting that much of a change or more. Our p-value is going to be 2542 or more extreme. And this is my X bar. So my X bar was 2,500. My population mean was 2,500. The standard deviation of the sample was 109 divided by the square root of 37. So we're going to look at this. We're going to run this test. So stat test, t-test. And in this case, our population mean was 2,500. Our sample mean was 2,542. We said we had a sample standard deviation of 109. and our sample size was 37. And we wanted to know if it was increasing, so we needed a greater than. All right. So I end up getting a t statistic of 2.343. By the way, this says negative, it should be positive. So the probability that t is greater than 2.344 equals 0.0123 or 0.0124. Please go to 4 decimal places, truncate if you like. And in this case, they said use an alpha level of 0.01. So they gave us an alpha level of 0.01, 0.0124. Please note, when you have it like this, make them the same length. Since this goes to 4 decimal places, I want 4 decimal places here. And 124 is greater than 100. All right, because it's greater than 100, what do? If the p-value is greater, and this is what it says on the recipe, if the p-value is greater than alpha, we failed to reject the null. So we're going to sit there and make that statement. We failed to reject the HO, or we failed to reject the null. And then we're going to use our template at the bottom of our page, the bottom of our recipe. Our p-value is, well, what did we calculate? We calculated 0.0124. What was our decision? We failed to reject the null. Why? There is not sufficient evidence at alpha equal. We use an alpha of 0.01 this time, so make sure we make that change to suggest that the true population mean for credit card usage, true population mean for credit card usage right above is, and please note, this part always comes from the alternative. Because what does this say in words? This says is greater than $2,500. Okay. So that concludes this one. Hopefully that was really helpful. We're going to do the next video will be on one sample T as well, but we're going to look at a not equal or a two-tailed test, and it has a little bit of a change to it. Hope to see you there. Thank you.